Hey there, YouTube squad. Good morning, YouTube squad. Uh, doing another daily stream here, and we'll be talking about things that viewers bring up, perhaps if they are noteworthy, especially, and be talking about the weather, both in space and on Earth, and about the title. The title of today's stream is "Recovery Equals Resilience." And that applies to all kinds of things, not just things like bike racing and your fitness. These things apply to everything. Recovery equals resilience. So when you're trying to get your fitness to maximum levels, recovery is training. So yes, your hard efforts are super important. Those hard times that make the strong humans, those are super important because they are how you get strong in the first place. However, for big gains to take effect, you have to wait. Usually like over a month, like 5 weeks approximately. So if you're an endurance athlete, in order to get the gains that you'd like to see to make you a better endurance athlete, you have to recover. So it's not just the hard bike rides, it's also the easy bike rides. Those are as important as the difficult ones. So that's my point. Uh, and without the proper recovery, your training isn't going to be maximized. You are not going to see the gains that you want to see without the proper recoveries. That's all I'm saying. And this applies to anything, whether it's an economy. It's one of these matters of hard times make strong humans, which make good times, which make weak humans, which make bad times, which make strong humans. So again, this sort of applies to everything. If you're a YouTuber, same deal. Same deal. Anyway, we're looking at the last few hours of the sun here. We did have another X-class solar flare. We'll be looking at if there are CMEs associated with that, coronal mass ejections. The likelihood of additional solar flares remains there, although it has dropped a little bit. We still do obviously see X-class flare potential from this sunspot group. It's produced a number of X-class events already, pushing a half dozen at this point. So that'll be a point of interest. Moving forward, we can see some coronal mass ejections actually happening here as we make the video. This is the past 12 hours. We'll let that play all the way through. And then we'll talk about some other space weather stats. We do have your chats available to be on the screen here. So if you're new to the channel, press subscribe so you see the world's most comprehensive daily space weather content in your YouTube subscription feed. Otherwise, press like, share, and leave us a comment. Tell us what you're up to. Wait till you see the temperatures in Lehigh Valley, Pennsylvania today. They are in the single digits Fahrenheit, so it's on the cool side. When I was accompanying Smash staff to work, I thought my nose might freeze. So it is a little bit chilly, and that is an understatement. It's legit cold. All right, so let's talk about some other stats here. Like I said, there have been additional X-class solar flares and a series of long-duration M-class events also. So there's the last X flare was just about 24 hours ago, and there are those M-class events, some long-duration ones. I suspect there may be some coronal mass ejections, and if so, more ejecta headed toward Earth. By the way, the coronal mass ejection that we forecasted to strike today, early in the day, struck early in the day today. So NOAA was expecting it to move more slowly than it apparently did, because we already saw that strike. It did cause a minor geomagnetic storm condition. KP5 occurred. It was unlikely to spawn any, especially long duration mid latitude aurorae. So unlikely to have seen much of that, but the best place that I know of to follow auroral photography is on Twitter. So follow us over there, x.com/smashomash. Thanks for the comment, Ponjoy B3 Think 7. Don't be putting spam in the chat. You get one warning. All right, so here's the latest imagery. Let's take a look at just the magnetogram. And you can see there is some magnetic shear at the tail end of this sunspot group. The leading end. The leading edge has a little bit of magnetic shear here right at the front, but this is the place to watch this back part of sunspot 4633. This does have some magnetic shear as well. That's a beta gamma sunspot group. This one is a beta gamma delta sunspot group. And there it is up close and personal on the SDO camera. So here we'll add 171. That's 171 angstroms. That's the extreme ultraviolet. And you can see how the field lines are much more jumbled here around this area than they are in this leading group, which is massive, as you can see, much larger than the Earth. Here's the SDO continuum. And yeah, those are some large sunspots, and we can see plasma bridges going across this group as well, this front bit. So yeah, that's close up of that very active X-class flare producing sunspot. Thanks for your additional comments. BThink37, or else I'm a girl weirdo. Okay. Cheers. Cosmic ray flux remains at a 22-year low. Don't expect this to go up anytime soon. We're seeing a likely stronger solar cycle than solar cycle 23. As you can see, the majority of the cosmic ray minimum in this cycle is lower than the cosmic ray minimum of solar cycle 23, represented here between the year 2000 and 2005. That's around solar maximum of cycle 23. And this one looks stronger, at least in terms of how much plasma the sun's been putting out. There is a lot. Here's one of our cosmic ray producers. It's Cygnus X3. And I heard some stuff about Sagittarius A star. So let's just take a look at the X-ray emissions of Sagittarius A star. For those of you new to cosmology, or perhaps who don't know about the Milky Way galaxy's core, it's called Sagittarius A star. That's what we call the massive radio source at the core of the Milky Way galaxy, the object around which massive stars are orbiting at hundreds of kilometers per second. I think one of them's even at like 1,400 kilometers per second. So let's take a look at the X-ray emissions from that. There we go. There's Sagittarius A star, and there are its X-ray emissions. So you can see a bit of a bigger range here over the past 5 years, back to 2021 or so. Those are the X-ray emissions from the core of the Milky Way galaxy. We get a better view of X-ray than visible light from that because there's a lot of gas, dust, and massive stars right there around Sagittarius A star. But yeah, this is Cygnus X3. This is the cosmic ray point source in the Milky Way galaxy. It's about 32,000 light years away. Sagittarius A star is about 26,000 light years away. Anyway, let's see if we do indeed have additional Earth-directed coronal mass ejections, since we have that couple of M-class long-duration solar flares. Here's the U Redding. And if there are new CMEs, they were just recent and they do not look like they are modeled yet by the Huxt forecast. So I suspect later in the day we may see some, but we're going to show you whether or not we think new CMEs have erupted. Especially considering how accurate the forecasting has been on this channel. So the current solar wind here, we're going to show you this CME that struck basically exactly when we said, around 3 o'clock, around 2 o'clock Universal Time this morning. You can see the field went up to total field of 18 nanotesla with a BZ of -16. So that's a significant current induction into Earth's system from that magnetic field. It was not accompanied by a large increase in the solar wind density, but the solar wind velocity did go up a bit. That CME was at about 500 kilometers per second. So the forecast on this channel was exactly right within a couple hours of that coronal mass ejection ejecting. Solar wind is measured out here at Lagrangian point 1 just to orient yourselves as to where things are. L1 is about 1 million miles from Earth, or 1/93rd of the way to the sun. Thanks for your comment, Spectrum 9. You don't have to retract it. This is Lagrange 1, and these are the spacecraft that are orbiting it that we use for the solar wind, that ACE and Discover. And the data that we just looked at, that was the ACE, which is depicted here in green. So these green dots, the ACE, that's where the ACE is located right now as it orbits Lagrangian point 1. Earth's magnetosphere here has reached a state of somewhat equilibrium here, as we see similar amount of magnetohydrodynamic pressure on both the bow shock side, which would be the left, and the magneto-tail side, which would be the right side, the nighttime side of the planet. That is the past 4 hours, I believe. Yeah, there's the past 4 hours of the Earth system modeled out to about 12 Earth diameters by the Space Weather Modeling Framework, one of the products you can receive from University of Michigan. Yeah, thanks for your comment, Spectrum 9. This is the stuff that I look at, so I share it. And this channel was largely started because there was no coherent daily space weather coverage on YouTube. I wanted to view some of this data on a larger screen, so that's part of the reason why we do this. We will eventually start streaming in both landscape and portrait mode. But right now, it's not that much of a priority. And it has to do with things like recovery. So, resilience equals recovery, recovery equals resilience. And whether it's putting out YouTube content or whether it's being an elite bike racer, it's complicated. And recovery, people think that bike racers just go out and ride real fast all the time. That's how we do things, and that's couldn't be further from the truth. We spend most of our time riding slowly, especially during race season. I mean, that's how you get fast. You have to have structured efforts that are, maximum intensity, but you have to have lots of recovery periods to keep the blood flowing to the right places and, build connective tissue. It's very complicated getting strong. So, keep that in mind and have some patience, because if you are trying to get like really fast, or really with anything, you have to allow the gains that you've achieved through your hard work to take effect. These things don't happen instantly. So anyway, NOAA is forecasting geomagnetic storms throughout the day today, but these arrived already. So we're already seeing the CME. It was just moving a little bit faster than NOAA forecasted. It was about the speed that we initially forecasted. So it showed up basically when we said it was going to show up, early in the day today on the 5th. And you can see our video from 3 days ago. That's exactly what I said when I saw the CME. So there's that. Next is we'll look at sunspot number and radio flux. Here's radio flux first. And the radio flux is reported by solon.info/solar is up to 178 solar flux units. So up a little bit from yesterday. And I think the sunspot number will be rising toward 200 as well. No, sunspot number came down. Okay, so yeah, that's because 4633 degraded and lost some of its umbre. So sunspot number here down instead because of the degradation of that sunspot in the north, the X-ray producer, the X-flare producer. And so sunspot number currently at about 138 sunspots, not approaching 200. I was wrong with that forecast. Next is our coronagraph. Here is the GOES 19. We'll look at stereo A after this. All right, so there may be another Earth-directed CME, maybe one, but let's look at it from stereo A's view. Hopefully the data is available. So we'll go to the Integrated Space Weather Analysis Center and look at stereo A. There's stereo A with a planet coming into view, and that planet is I suspect it's Mercury. Looks like it's moving very fast. Just a moment here. Let me get this sized for a portrait orientation stream. There we go. All right, so we have stereo A data here. Stops at 1553 yesterday. And then restarts at 3 this morning. At least that's something. Yeah, that planet's moving real fast. I suspect that's probably Mercury based on where stereo A is oriented. And I don't think that is an earthly directed CME. So it looks like no new space weather headed this way according to the data that we have. Here's where our planets are located in the solar system. Keep in mind, planets aren't really space weather. They all have their own space weather. Earth's space weather just occurs between Earth and space, Earth and the sun, from the photosphere to the D layer of the ionosphere. No spikes in the proton flux, but don't be surprised to see one, as we do have a large filament setting on that western limb, which we'll show you here momentarily. Those long duration M-class flares, they happened at about 4:30 this morning. 4:30, we had an M2.7. If that produced any Earth-directed CMEs, we didn't see them on the data, so we're not going to forecast them. I see some more chats here. When I bring up this, I will put that on the screen. Let me just put up today's data for the heliosphere magnetism. This data is derived from Earth-based magnetometers, as well as magnetometers on stereo A, which is over here, and stereo B, which is over here on the left. Earth is right in the center of a South Pole-oriented magnetic sector, as the heliosphere is currently ruled by the sun's magnetic field lines, which are pointing toward the sun, as they are South Pole, or you could say negative polarity. And those are the solar polar fields. The southern ones are pointing right toward the Earth. Welcome to the South Pole of the heliosphere. We're right in the middle of this side of the sun's South Pole. And those coronal hole magnetic lines, they just are open field lines. They just point into space. High-speed wind coming from those coronal holes in a couple of days. Here's our line of sight coronal hole plot. We're going to show the same time period here. Just today, that's just 11 frames there. That'll give you a good little animation. The sun's B field is depicted here in blue. That's interaction, the net field of the sun. And then the polar fields aren't really modeled, but the coronal holes are modeled here in color. So the red, those are the South Pole coronal holes that we refer to. You can see North Pole-oriented coronal holes here, lining the southern heliographic polar region and that western limb. Well, thanks. I'm glad you appreciate all the relevant data of space weather being shown and explained in a coherent fashion. Yeah, it's fun. So here's our magnetograms. And like I said, sunspot 4633 degraded This one does have flare potential down here, so eyes on that one, but this is the place to really watch. There is still quite a bit of plasma filamentary suspension above this by those magnetic fields, and certainly potential for some major reorientation of those magnetic fields, and that is sort of what happens during a solar flare. So yeah, glad you like the content. Space weather is only going to become more popular and more common and more important over time because of private space flight, right? So in a year or two, you'll be able to get into space for a short space flight for 5 figures. And when that happens, then it'll be even more important to understand space weather. But it's already getting increasingly important because of the reliance on Starlink satellites. And for so many reasons, so many people rely on space for so many things. So it's only going to become more and more important over time. So there is the El Teide red light imagery. That is what about 140 sunspots look like. That's a little under 140 sunspots right there. Looks like they had some clouds there at El Teide. But if you look at the last image, there's the last image. That's pretty clear. I like that. There we go. Sunspot 4633 is a very lengthy sunspot group. It's hundreds of thousands of kilometers in longitude. Next, filaments. And we're going to bring up the full newest data here because I want to see if any have ejected. And you can see the Eric Schmidt filament there, perhaps setting on that western limb. So if you want to name solar filaments, do it over on Twitter. Just use the hashtag name that filament. Put some kind of graphics on there that explains which filament you want to be named. And, well, let's show you how it's done. So what you want to do is take the last image here, the most up-to-date image, and then pick your favorite filament. Pick the filament you want to name, and then do something like this. Take a screenshot. I'm going to use Shift Windows S, I'm sorry. And then I'll take a screenshot, and then I'll use Microsoft's Snip and Sketch. We're running Windows 10 on this machine, by the way, although perhaps not for long. But it's working adequately. And then you just pick a filament. So there we go. There's the filament. That's a pretty crappy looking arrow, though. Let me, that sucks too. Let's try again. That's terrible. Let's try again. That sucks. See, resilience, folks. It's all about resilience. Trying to draw an arrow with a mouse is not my favorite. All right, so that's good enough. That filament right there, that's the one we'll name. If you'd like to name it after somebody, just retweet the post I'm about to put up. So we're over on X. We're all over the internet. Just check smashomash.com. In fact, let me put it in the chat here while I update Twitter. Let me put this in the chat. I can be an astronaut like Katy Perry. You totally can be an astronaut like Katy Perry. She did go to space. She did go to space. It was pretty low in space, but it's still space. It was above the D layer of the ionosphere, so it counts as space. There was definitely no air where she was. No air that would be breathable in any way. It basically was a vacuum. All right, so anyway, visit our homepage. I'm going to drop it in the chat right now. And we'll pin that comment so that you can visit the homepage. That way you'll see where we are on social media and so forth. When you press that share button, you can tell your friends and foes that the content exists. And for that, we thank you. Anyway, I don't have an idea for who to name this filament after today. Actually, it's too late. I'm naming it. It's too late, folks. Damn it. We're going to name this filament after Eugene the philosopher. And that's because he's my friend from Belarus. And not only that, Eugene the philosopher is the greatest living philosopher since the unfortunate passing of Quentin Robert de Nameland. I don't know if you're aware of that, but check out his YouTube channel, Eugene the philosopher. Yeah, there's a T in it. It's some kind of Zappa reference or something. But anyway, that's how you name a filament. We name them after living people, your friends, your foes, or even yourself. Solar coronal plasma filaments. It could turn into a geomagnetic storm, and we hope it does. So yeah, thanks for your comments, everybody who's left some. I can be an astronaut like Katy Perry. Indeed. That was nice of you in remembrance. Well, thank you. All right, so yeah, we have a really big and very dense filament here rising just north of the solar equator here, very close to the solar equator. On that eastern limb, that's a good one to name. Due to its location, it's not likely to produce an Earth-directed solar storm at the moment, but this one down here is now named after Eugene the philosopher. Shout out to Eugene. May all your battles be well-chosen victories. At Smash-O-Mash on X. Check out the homepage. And we do see a dip in the electron flux here. Keep in mind, folks, this is an erroneous reading generated by the geomagnetic storm conditions. This is just because the ionosphere puffed up when that geomagnetic storm struck. So this is actually erroneous. The electron flux is actually much higher than this, but because the D layer moves around when we get perturbations in the magnetosphere, as we did from the geomagnetic storm, we're getting erroneous readings here. So this is going to go back into warning levels later in the day today as that coronal mass ejection impact subsides, which it will do shortly, as it wasn't a major event in the first place. So this is where you can expect bad GPS performance. This is the CTIPE, which stands for Coupled Thermosphere, Ionosphere, Plasmasphere Electrodynamics Model. This is the free electrons from ground level all the way up to the outer portion of the outer Van Allen belts. So your GPS satellites, they orbit at like 25,000 miles of altitude. And this is depicting all of the free electrons in between you and it. It is a model, but it is a good prediction. Next is our DRAP. That's the deabsorption regions prediction forecast. And this is where you get equatorial radio blackouts caused by the attenuation of the D layer. So this is the D layer of the ionosphere, down here around 90 kilometers in the daytime. And this moves around just like the F region does, which is where the electron flux is measured. But the D region is what we're looking at here for communications purposes. And that's where you can expect radio signal blackouts for high frequency radio transmissions. It's showing you the frequencies here and the amount of attenuation in decibels. So expect continued equatorial blackouts as solar flares will continue to roll in. And like I said earlier, don't be surprised to see large flares, including X-class events from the trailing umbrae associated with sunspot 4633. We're going to transition into Earth weather, but first the ionosphere map, and let's animate it today. We haven't seen the animation for a couple of days here, as we've been tracking the motion of the South Atlantic anomaly, which is kind of important, or at least super interesting. So here's the previous day. We're going to show the raw frequency and the anomalygram. So there's the raw megahertz. Tabmaster D. Call me Tabmaster D. That's or you could call me Dr. Data. That's a good one. Let me chug some Pepsi while I let the ionosphere map play and take a look at that. Yes. People will get mad because I'm chugging Pepsi. Shout out to the Rageaholic, Razor Fist. One of my favorite YouTube ranters ever. I think he might be the best ranter ever on YouTube. But this is what's going on with the ionosphere, and what's important here is where the South Atlantic anomaly is. And it looks like it's over here. It spent a long time here over the South American continent, and it spent some time down here in the South Atlantic. But now it's up here in the Central Pacific Ocean on the west coast of South America. The African anomaly is not quite as distinct, but it looks like it's at the equator as well. So I don't know. If I'm wrong, tell me in the comments. But this is the raw data of the frequency of the F layer. So, I mean, this is super important because it's the F layer. Now, when we show the anomalygram, it'll be even more apparent where the South Atlantic and where the African anomalies are located. And we've got lots of high frequency anomalies here, and that's got to do with the geomagnetic storm conditions. You'll also see some big sudden variations as the ionosphere bounces around from that magnetic input of that geomagnetic storm, that coronal mass ejection launched on the 2nd of February. So a great display here of how the data corroborates with the other data sets. And South Atlantic anomaly. Well, the African anomaly clearly is right here on the equator. I mean, you can see right there, there's that big variation. Yeah, South Atlantic anomaly is up here. It is not down here. It is up here. So anyway, that's where it clearly is. I mean, there's the map. You can see these variations. They're happening right here near the equatorial west coast of South America. The African anomaly is right here at the equatorial west coast of Africa. I mean, read them and weep. That's the data. If that freaks you out, I don't know why. It's just Earth's magnetosphere has variations that happen, and the South Atlantic anomaly and African anomaly, they're going to move around because Earth's magnetic poles are constantly shifting. Like saying the poles are shifting is a non-starter. They're always shifting. They've probably never just sat in one place forever. So, but it's very hard to tell without lots of data on it. We've only been gathering lots of data since the space age. Of course, people had compasses back into the 1800s, but I digress. Let's get to Earth weather. Now that we've shown once again the wandering of the South Atlantic anomaly. Well, maybe it's news. Maybe it's news to pole shift alarmists and catastrophists alike. And just so you know, folks, catastrophists. Oh, I see a question here. What are the calculated effects being exposed to humans of today's exposure? So people that are on the ground don't really get very many effects at all from exposure to space weather. If you're doing polar flights or you're an astronaut, you're in space, you're going to get more radiation when a coronal mass ejection strikes like it did today. But the ground effects are very minimal. The CME does induce currents into Earth. So Earth does have telluric currents, electrical currents that come out of the ground. They're very weak. You can measure them using a ground-based magnetometer. And with those currents are accompanying magnetic fields, because electricity and magnetism are just at right angles to each other, oscillating back and forth. So, where you have a magnetic field, you have an electric field. Where you have an electric field, you have a magnetic field. Where you have electric current, you have a magnetic field. Where you have a magnetic field, you have electric current oscillating back and forth. That's just how electromagnetic radiation works. So, yeah, it does affect the ground currents, and it affects them more around the auroral ovals. So, the polar regions, they have stronger telluric currents coming out of the Earth and going into the Earth, depending on which pole it is. But yeah, so there are some minor effects. But you're not really affected a whole lot by magnetic fields. You can stand next to an extremely strong magnet, like an MRI, and it doesn't really hurt you. It's gonna affect things on the subatomic level a tiny bit, but you're made for this. You're an Earthling, so these telluric currents are part of your natural state. So yeah, there really aren't very many effects of being exposed to today's space weather. It's commonly misunderstood. Some people think the solar wind is like making the wind kick up in their backyard or something. And there's a lot of, I'll just say this, the density of the solar wind is extremely low compared to sea level. It's about 1/4 of the density of the air at sea level. So, for every one proton at Lagrangian point one where the solar wind is measured, there are 1/4 protons at sea level, about 1/4 or so. So that's a huge difference in density there. Um, these induced currents and so forth, they're largely expressed out in the Van Allen belts and in space. So Earth does behave as a capacitor, and you're in between the positively charged sky and the negatively charged ground. So the ground is negatively charged and the sky is positively charged. Um, so there's that. The system, like everything else in the universe and nature, it's trying to reach static equilibrium. And so, that there is some electrical current constantly flowing into and out of the sky. I mean, see lightning for details. But yeah, so it does affect things, but it's a very minor effect. And like I said, you can measure it. So most smartphones uh, have a magnetic sensor in them, and you can download apps that will measure magnetic fields, very tiny magnetic fields, like in the nanotesla range. So yeah, you can measure it. And if you have baseline data for where you're located, like what the telluric currents are usually like, then you'll be able to actually see the space weather, and that's sort of an auroral forecast too. You can predict when the aurora are likely when you see big changes in the telluric currents beneath your feet. So there's that. And also another thing to keep in mind is how Earth's magnetic field is generated in the first place. As the electric current and magnetic fields propagate through the substrate beneath your feet, um, that substrate conducts electricity and magnetism differently. So if you're standing on a massive mountain that's got a huge amount of magnetite in it, that's going to be a different expression of those telluric fields from your perspective than it would be if you're standing on a huge mountain made of quartz, which is also different than if you're standing on one made of sandstone. Granite is also a different thing. Granite has a very strange way of propagating electricity and magnetism through it because parts of it are porous and parts of it are not porous. So the electricity takes weird paths. When it goes through sandstone, it's like a sponge. It's quite interesting. And that substrate beneath the bedrock and the earth's crust beneath you, it does affect the way the telluric currents work. And that causes a different amount of induced current in the electrical grid of the U.S., for example. The way the Appalachians see those currents and electricity expressed into the electric grid is different than the Midwest, and it has to do with the conductivity of the Earth's crust, the conductivity and how ferrite it is, and a lot of things come into play there. So just a little bit about that, and thanks for the question. That's a good question. Next question is, what is the theory or hypothesis in relation to solar flares and volcanic activity? There isn't a relation between solar flares and volcanic activity. We don't see any evidence to indicate that a volcanic eruption happens under the part of the Earth where a solar flare just occurred. And that's super clear because solar flares are short-lived events. It would be super obvious if a solar flare happens and then a volcano happens underneath it. Those X-rays that are the solar flare. So a solar flare. Think of like a flashlight. It's just light. It's photons. Those X-rays don't make it to the ground. You can't measure solar X-ray flux from the ground. That's why we use spacecraft for it. So you can't measure the solar flare from the ground. It has to be measured from space, because when the X-rays, when those X-ray photons start hitting the Earth's magnetosphere, they only make it down to the ionosphere, the mesosphere level, something like that. They don't. They're those X-rays are adsorbed before they make it all the way down to ground level. They don't make it anywhere near ground level. So, yeah, it's there. There's no plausible physics that I'm aware of, or any correlation between solar flares and volcanic activity. There's no evidence to suggest that it's a thing. It's not even a correlation, and there's no physics to explain how it could be a causation. Negative and positive. I got that. Thank you for the clarity. Cheers. Anyway, here's the blue marble with the Atlantic sunrise. We like to show this. Once again, helps orient people. Of course, our regular viewers are well aware that Earth is actually croissant shaped, so visit the Red Bubble shop in the description. And maybe come to your senses. Pick up some merch. Help support the channel. Tell your friends and foes about us. You can even save some cash on Redbubble by spinning the wheel. But I just wanted to show you one of the products here. Yes, there is mature content, which I will not show you in this video. Anyway, don't be an imbecile, and definitely do know that imbecile is an adjective. And do join the Croissant Earth Society. Stop believing NASA's lies one of these centuries, and understand that Earth is shaped like the French breakfast pastry. What do you think, Neil deGrasse Tyson isn't lying for NASA, trying to tell you Earth is shaped like an oblate spheroid? Oh yeah, sure, it's an oblate spheroid. Everybody with their head out of their ass for 5 seconds knows that Earth is shaped like a croissant. So stop believing NASA's and Neil deGrasse Tyson's lies and join the Croissant Earth Society today. Tell your friends and foes about that one. We don't troll on the same level on this channel, folks. We troll like somebody who's been on the internet before social media existed. Sticking with Earth weather here. There's a U.S. water vapor map, and this is the map you use when your Doppler radar is unclear. If you don't know what your Doppler is going to show, like, check it out. Check this out, folks. Future Golf Resort and Trump Water Bottling Company. The Trump Ice Sheet Water Bottling Company. Greenland ice sheet. It looks delicious. I want to drink it so bad. I want to drink the Greenland ice sheet. It just looks so tasty. Could you please get this shit off of my screen? I don't know what that is, and I don't want that on there at all. But it's there. Please go away. I pressed refresh and it didn't fucking work. Ew, look at that map. It looks like shite. My God. Please get rid of that. Layer options, hazard. Ah, that is ass. My mistake. I don't know what I clicked something and I wish I hadn't because it sucks. I press refresh and those stupid maps, those are like the warning maps. I'm trying to show the data here, not the National Weather Service warnings map. Please go away. Please go away. If anybody wants to do tech support, tell us how to operate this friggin' map. You know, I like to use weather.gov, radar.weather.gov, because it's the National Weather Service map. Oh, I know what to do. You just go to radar.weather.gov and get rid of the settings. That's how you do it. There we go. All right, so there's a Doppler radar. Please heed your weather warnings. I'm not going to show you the map. You're capable of going to weather.gov yourself, but here's radar.weather.gov. And we do have continued white stuff coming down in places besides on the set of adult films. We've got a bunch of white stuff coming down here in Chicago and points north, and some rain making its way across Florida. Florida, it's the Australia of the US. Maybe with lower taxes. Lower taxes, folks. Making everything super expensive in Florida. Everybody wants to be where the taxes are the lowest to send the least amount of money to utterly incompetent governments. Can you blame them? Anyway, yeah, there's that snow, and oh my God, I've done it again, folks. I've clicked on a thing and like shattered my map. Isn't that fun? Don't put a control on there for me to get rid of that shit or anything, no. That's too much to ask. My God. So yeah, there's the US Doppler radar map. And what I was saying was when your Doppler radar map is not clear. So let's look at this snow that's around Chicago, right? So let's look at one of these transitional zones here, shall we? Yeah, we shall. So we're going to go right on we're going to center this map on Chicago. And then we're going to center this map on Chicago. I want to show you the relationship between the water vapor map and the Doppler radar. Okay? So here's a water vapor map. Here's a Doppler radar map. And you can see how distinctly differently those look. I would hope. And why is that? Well, the reason why is because this is showing water vapor and this is showing vertical motion of droplets and crystals. So ice crystals, water droplets, snowflakes. The vertical motion of those is what the Doppler radar shows. This shows the water vapor. So basically what's happening here is there's a collision happening. This air is smashing into this dry mass of air to its south, and that's creating a huge pressure barrier. Keep in mind, warm air is less massive than cool air, and dry air is more massive than moist air at a given pressure and temperature. So there is anyway, that's the Doppler radar. That's the Great Lakes snow that's happening. And it's pretty snowy. Pretty snowy across the lower 48, to which some people would refer to as a country. You got to include Alaska, Hawaii, and Canada. And I heard Greenland, it's going to be changed to Trumpland. I don't know. Let me know. Let me know in the comments if it's going to be changed to Trumpland. So I guess we aren't in the single digits. We're actually at about 14 degrees Fahrenheit here. So only negative 10 Celsius. Today's forecast high is 29. Tomorrow 28, and Saturday a high near 15. A high near 15 Fahrenheit on Saturday. Also, there's some new snow coming, and we're going to show some forecasts here. First, we'll show the satellite imagery from windy.com. I like it. No, I don't want you to know my location or to send me notifications. So here we're going to get rid of the radar overlay and just show you the raw satellite data. Give that a minute to load. It's well worth it. It's pretty doggone good. All right, meanwhile, I see some more comments have come in here. Let me bring those up on the screen. While that loads, I don't know why it's taken so long. We've got a blazingly fast internet connection with like 400 up and down, 400 megs up and down. Years ago, I saw another different theory of our solar system. I can no longer find it anywhere. Has any one of you heard of it? Good Thursday morning. Good morning. Um, Another theory of the solar system. Okay. Anyway, there's some great satellite imagery for you. You can see that cold air driving in from Canada, and you can see this huge amount of moisture here. This Pineapple Express, massive atmospheric river in the Pacific. So, I mean, just look at that thing. This is one of those things that some people will look at this map and say, look, it's a man-made storm front. And humans are not capable of producing this much water vapor. That's too many clouds for people to make. There are people on Twitter that will look at this weather front right here, and they'll say, look, that's a geoengineered storm. Humans made this. Really? They made a 6,000 mile long they made a 6,000 mile long series of clouds. Yeah, that's not a thing, if you're wondering. Is there any lightning going on in the US? No. Lightningmaps.org tell us that it's calm as far as lightning strikes. Next, we'll head to Tropical Tidbits and show the latest snow forecast. That wasn't the latest one, but this will be. So there. I just want to see the positive snow depth change, because I think we're getting another inch here in eastern PA. So there is the 72-hour GFS accumulated positive snow depth change forecast in inches. As you can see, that Canadian air is going to push some more snow into the mid-Atlantic. So Boston to DC corridor, heaviest snows will fall in the mountains of Appalachia. That's West Virginia. Yeah, West Virginia. That is a rather impoverished part of the country. But they're going to get like 8 inches of snow there. No new snow in Toronto. Thank you for the update. Thank you for the update, the Marion Lewis. We'll close out the weather portion by looking at the winds of planet Earth. Very windy in the North Atlantic and the North Pacific, just like yesterday. These, like sands through the hourglass of time, these are the surface winds of your lives. And these are the jet streams. Huge anticyclone here right over the Great Salt Lake, actually. See that upper level clockwise rotation? That is a massive, massive upper level high pressure zone. So this is like essentially like a pushing down. In the Northern Hemisphere, when you see a clockwise rotation, that is an anticyclone. Almost like Jupiter's Great Red Spot, but nowhere near as strong, because Jupiter's super violent. It's got a lot of convection winds and really strong magnetic fields and all kinds of funky stuff going on. Here are the jet streams of the east. Shout out to our viewers from all around the planet. Here are your surface winds. Strong onshore wind at the Philippines could make for lousy surf. Surface winds of Europe, Africa, and the Near East depicted here. And the jet streams of the central world depicted here. Well, it's time to close this thing out. If you've got no other comments, questions, etc. Pardon my appearance. I know I look like a Joule. Don't worry, I'm growing facial hair to remind me to get a haircut. But it's the dead of winter right now. So you got to have priorities. Priorities like basic survival. So once again, let me just reiterate what the title says, which is Recovery Equals Resilience, folks. Bad times make strong humans, who make good times, which make weak humans, which make bad times. Repeat the cycle. Be the strong humans. You may have already been the strong humans many times throughout many previous similar cycles. So hopefully you've been solutions. And remember, folks, every crisis is an opportunity for you to be a leader, to do new innovative things, to invent something, to make a YouTube channel. There's definitely something interesting that somebody wants to hear about that you do. So if you're putting off creating a YouTube channel, create one today. We might even promote it. It'll probably be interesting. What you don't want to, don't put any AI on it. Like, keep the AI slop off your channel, because it's going to be increasingly hated, I think, over time. People are sick of all the gray goo on the internet ruining content itself. So there's that. We'll close out with some additional imagery of the closest star here. I'm going to do some runs of different wavelengths. So let's do some other wavelengths here. We'll show 171, the house favorite wavelength. That is ionized iron, by the way, which brings up something interesting about the sun. While it is mostly made of hydrogen and helium, there are a cocktail of other interesting chemicals all over the closest star. That's iron, okay? These are the extreme ultraviolet emissions of extremely hot iron gas in the sun's corona. What's interesting about 171 angstroms is that particular type of atom, it likes to orbit the magnetic field lines. As you can see, it orients itself to all of these field lines. So that's why it's such a cool wavelength to view. And there's a close-up of 4633. You can see there are quite a lot of lines over here. So there's a lot of plasma suspended way up above, hundreds of thousands of kilometers above that sunspot. And we are waiting for it to eject, and frankly, hoping that it does. If you're spooked to the sun, this is not the channel for you. This thing is not going to kill you. It's the source of all life and energy on Earth, more or less. So it's your friend. It's your friend, not your foe. If you're spooked to the sun, please stop being spooked to the sun. If you're mad at clouds, please stop being mad at clouds. Contrails are not geoengineering. Contrails are not even made intentionally. So please don't look up at the sky and be like, oh my God, clouds make me mad. Like that's a thing constantly argued about on Twitter, because millions and millions of people think that contrails are intentional and that they're an effort to block out the sun or some nonsense like that. Not only are contrails not intentional, contrails are so not intentional that airlines are going out of their way to not produce contrails. Now, you could make the argument that contrails are pollution, right? Contrails, they do make it cooler in the daytime. They can cloud up a whole city. One contrail can propagate a cloud that takes up the entire sky. That's a thing. It's called an overcast day. And it can be triggered on a really stagnant, humid day by one plane flight. That's a thing. You could make the argument that contrails are pollution. They make it a little warmer at nighttime because they reflect some infrared radiation back to the crust. Normally at night, if you have a clear night, Earth's crust dissipates heat, otherwise known as infrared radiation, into space. But if there are clouds, it stays warm at night because a lot of that infrared radiation bounces back and forth between the cloud cover and the ground. That's why it stays warm on cloudy nights, because the crust isn't able to dissipate all of its heat into space. This is why deserts get really cold at night. So contrails make nights a little warmer and they make days a little cooler. What's the net effect? Who knows? It's different near the glide path of an airport, though. If you see a lot of contrails overhead, it's because there are a lot of flights and humid air, where the plane flying through the air has caused the air to reach dew point. There's moisture in the combustion process, so that's, water comes out of the engine. And then, plus you're perturbing the atmosphere. You have a huge high pressure zone in front of the plane, and especially in front of the jet turbines. And then behind the jet turbines, you have a huge low pressure zone and a huge low pressure zone behind the fuselages. And that causes the air to reach dew point. When you see a persistent contrail, it tells you about the atmospheric conditions, namely pressure, temperature, humidity, and the wind speed and direction. It doesn't tell you about exhaust components. It tells you what the atmosphere is like. It's a contrail's persistence is giving you weather data. It's not telling you what's in the plane. So I just figured I'd bring that up. Most of our viewers are probably able to pass, junior high level science and understand how a cloud forms. But lots of people on the internet definitely don't know how a cloud forms. Here's another favorite wavelength. This is also ionized iron. This is a different number of electrons in the outer shells than the 171 angstroms. It's 94 angstroms, a different temperature, but also part of the extreme ultraviolet spectrum, just like all of the GOES 19 SUVI. That's why it's SUVI, because it's the ultraviolet imager, the solar ultraviolet imager. So that's one of the best wavelengths through which to view solar flares, and you'll see some action here, some M-class events. But yeah, so fingers crossed for some coronal mass ejections to be associated with that flaring. We always like to see that on the channel. It makes for the higher likelihood of things like mid-latitude aurorae. So hopefully you're recovering well from whatever stresses that you're under, and I'm sure there are a lot. Yeah, that would be a good title for a song there, the Marion Lewis. The Clouds Make Me Mad is a great song lyric. Inverted Banana 5630. Do you have inverted penis syndrome or IPS? Do you have balls on top? Fake planet. You mean the one you're standing on? Yeah, real fake. Gas pressure next to a vacuum. Gas pressure is not next to a vacuum. Earth's atmosphere is a gradient. A gradient. Gas pressure next to a vacuum. That's a thing inside a spacecraft. So thanks for bringing that up. IPS, inverted penis syndrome. And we appreciate your leaving comments. All right, so what about 131 angstroms? Let's show that as well after this plays through one more time. Let's just go straight to 131. We'll also show 195 here. Let's show 195 first, and then we'll go back to 131. Sound good? Just kidding. This is a space weather dictatorship. So here is 195, and you can see some of the coronal holes here, like this one up here. That's a South Pole-oriented coronal hole system there. And they kind of come down like this. These are all South Pole orientation. And these are going to appear to open up over the next couple of days. So these are going to look like they've grown, but they're not necessarily growing. It's just because the corona is very bumpy. And like I said before, there's a lot of plasma suspended up here above this sunspot group. And, those huge plasma filaments, they're like this. So as the sun turns, you're going to be able to see down the barrel of these coronal holes better. So just so you know, it's going to look like they're opening up. And then Stefan Burns will be like, oh my God, it's the apocalypse. Coronal holes that people could see for forever that, do multiple rotations are now facing Earth, therefore apocalypse. Let's go back to 131. I just wanted to show the coronal holes real quick visually here with the GOES SUVI because it's very convenient. (131 This is another ionized iron species here. This is just a different number of electrons in the outer shell. And this is the hottest spectra that we look at. This is the hottest 131 angstroms that's actually the hottest temperature that is covered by the GOES 19 or indeed by the SDO. The SDO does show 131 angstroms as well. So 131 is really cool. It's good at this particular ionized iron species is it likes to orient itself on magnetic field lines as well, as you can see. So, you know, if you view this one on 171 at the same time, that's a pretty good composite. 171 plus 131. We can show you that on Helio Viewer. Get rid of that. So there you go. There is 171 plus 131. And it's quite good. There you can see the Eric Schmidt filament there as it's starting to overlap the edge of the closest star on that western limb. If this thing does release at this point, this could create a proton event. We often see proton events that are not even associated with solar flares. Sometimes just a filament eruption is enough to cause a solar energetic particle event, where we get those ongoing polar radio blackouts. And there's a close-up of 4633, that multiple X-flare producing sunspot group. Anyway, it's time to close this thing out. Thanks for tuning in, folks. Congratulations on realizing the channel exists. Don't forget to press the things like, subscribe, share, etc. We'll see you soon here at the Smash News Network, least busted name of news. And until next time, may that solar wind be at your back.